We want to explore two of the most important aspects of light, reflection and refraction. When light strikes a smooth surface, such as glass, part of the wave is going to be reflected, part of the wave is going to be refracted. Now, an image of this looks like this. This image shows in red the incident light coming in, and I'm imagining that the lower surface here is glass, the above surface is air, and what you're finding here is that part of the light gets reflected in green and part of it gets refracted in red. We now want to focus on the aspects of a reflected ray, and then we'll follow up with a refracted ray. So let's start with reflected rays first. There are two types of reflection: diffused reflection and specular reflection. What determines whether you have diffused and specular reflection will depend on the surface and the wavelength. So writing this out here, the type of reflections depends on 1, surface, and 2, wavelength of incident light. Let's start with the surface. Surface effects on reflection. One can get diffused reflections when light is reflected off of a rough surface. An example of this would mean like this. So if I have a rough surface like this, then incident light coming in will then be reflected in various directions here. So this would be a rough surface reflection, and this is what we call diffuse. On the other hand, if I have a smooth surface, incident light coming in will all reflect in the same direction. Not scattered in all directions, this type of reflection is called specular. An example of this is when you're driving your car at night. Imagine that you have a truck, and this truck is driving at night, and the surface is rough. What happens then is light comes in, it scatters in all directions because of the rough surface here. The fact that some of the light comes back into your eye allows you to see the road. On the other hand, if I have this same truck driving at night and it starts to rain, then the situation changes. The surface becomes smooth. Because the surface is smooth, what you're going to find here is the light is not diffused reflections, but specular reflections. It all goes in the forward direction, or very little gets back. And so what you find here is that in this situation, it's easy to see the road because of diffused reflections. In this situation over here, it's hard to see because most light goes forward. The second thing that affects reflection here is the wavelength effect. The wavelength effect on reflection. If you want to see something small, you need to shine light that has a short wavelength. Whereas if you shine long wavelengths on something small, you won't see the details. So in summary, short wavelength light sees small size objects. On the other hand, long wavelength light will not see small objects. Picture-wise, this is what I imagine by a short wavelength light. Its waves are short versus waves that are long. So the important thing here is that I'm looking at this distance right here compared to this distance here. And this distance is big. Sees small stuff, does not see small stuff. So when light is shined onto a rough surface versus a smooth surface, what do I actually see here? So shining light on rough surface, so the small wavelengths they see details, so you get diffused reflection. The long waves, they see no details, and you therefore get specular reflections. There are many examples of this in everyday life here, and two examples is one of the microwave and the other one is of radio telescopes. The microwave oven door. When you look at microwaves, microwaves are the order of centimeters, whereas if you look at visible light, it's of the order of nanometers. So microwaves do not see the small details of the door. So what do you get? You get specular reflections. And therefore, the microwaves are not coming out of the microwave. On the other hand, you have visible light sees the details and one gets diffused reflections. So you actually see the grid mark of the door. The next example that we want to look at is a radio telescope. When we visibly look at this radio telescope, we see a bunch of holes. Why? Because visible light, as before, sees the details, which implies we get diffused reflections. On the other hand, radio waves are very long, and because they're very long, the radio waves will not see the details. So therefore, you get specular reflections. Our primary concern as we move forward now is that we're only going to be dealing with specular reflection from smooth surfaces, such as glass, water, metal. So from now on, we only talk about specular reflection.